All right, Lady Ada, we're live.
Yay, Hangouts is working. We're hanging out. It's me, Lady Ada, and you, Mr. Phil, who's not a floating skull. You're just here.
Yeah.
And I got all these puppets back here, and we're here in the warehouse, which is where we do all our manufacturing and design and shipping and all the technology. So it's a good time. But we're taking a break right now. Do you know why?
Yeah.
Because it's show and tell time.
Yeah, it's our favorite half an hour of the week.
This is your time to shine. You show up, you show us projects. We show you projects all week. This is time for us to kick
Your
back.
turn.
Gonna get a margarita,
Yeah.
chill out and watch some cool projects.
All right, first up, Tony D, what you got cooking this week?
Hey, yeah, so I've got a project I was showing off the last few weeks. It's the MicroPython Smart Holiday Lights project, and this is this blue and white, all this craziness going on over here. So this is a wreath that I got, just a little like 22-inch kind of wreath. These will probably be like $1 in like 4 weeks or so after Christmas. So maybe pick them up after the holidays. But if you want to show your holiday spirit, I wrapped a NeoPixel strand around here. This is the 60 pixel per meter, so it's one of the dense ones. There's actually 210 pixels on this wreath, which that's a lot of pixels. That's maybe more pixels than you need for a wreath, but it does look good. So hey, if you're gonna do it next. This is the Griswold version of the Smart Holiday Lights. But anyways, it's smart because I can control this from a web page. This is using the ESP8266. I won't show the web page because you can go watch the video and see all that, see how I built it. But I'll just show you, you can change the colors on this. So I just updated. So here's red and green lights for this, or change the animation. It can do like maybe a smooth fade between the colors and stuff like that. So fun project, again, using ESP8266 and MicroPython. So you can connect to this from a web page that runs on your computer and then controls the lights. And it remembers this too. So if I power it down and start it back up, it'll go right back to this red and green kind of fading color animation. So check it out on youtube.com/Adafruit.
All right, and yeah, videos part 1, 2, and 3 are up right now.
Yeah, yep, exactly. And then this Friday we'll have a guide out that kind of walks through everything for it. So.
All right. Next up, no, Pedro, what you got printing this week?
Hello. Yeah, hey guys. So this week I put together a simple enclosure for the 2.4-inch TFT Featherwing and the Adafruit Huzzah with ESP8266. Yeah, so this is a little weather station, and the code was written by Daniel Eichhorn, who goes by Squix on GitHub. And it's probably one of the best and easiest kind of weather station projects I've seen. Since it's a feather, there's literally no wiring connection, so you just kind of snap the two pieces together. So the enclosure is just a little box, a little 2-piece enclosure, no hardware skills needed. And it's portable, so I have like a beefy 2,000 milliamp battery in the back there. And that's pretty much it. It's really fully featured, so it tells the date, the time, current weather, 3-day forecast, and it even tells you when the sun is going to set and rise and when the moon is going to rise and set. I don't know if I said that backwards, but it has little icons and typography. It looks really nice.
Wow.
Overall, it's a really nice, like, great use of the ESP. I like it a lot. So if you guys want to check that out, we released the project today. You can check it out. And Lamar, you actually did some code right here. It goes to sleep. So you can tap the screen because it is a touch screen. So I tap on it, it'll wake up and it'll download. It's pulling weather data from Wonderground. So all you have to do is just register an account. It's free. You can get the API and pop in your key and put in whatever stuff you want. It also supports Imperial, Freedom Units, and Metric. I have it on Freedom Units, so it looks lovely. I like it a lot.
Yeah, that's cute.
That's cool.
It's cute. So that's it. Check it out. We got the video up there on the Adafruit channel, and we did 3D Hangouts today too. So if you didn't watch it today, you can watch it tomorrow as well.
Yeah,
And
we'll
we'll
put on the
have
video
some
on
nice
Ask an Engineer too.
Awesome.
All right, good work.
Thank you. Yeah.
All right, well, we had, hey, look, Tony's wearing a wreath.
Tony is festive.
All right. Hey, Scott, how's it going? Did you want to show something?
Oh, I suppose. First, I want to say I'm sad about Pebble getting bought by Fitbit. I'm a huge Pebble fan.
Share your pain.
I'm a little sad. And I also wanted to note that if anybody is curious about what happened with my own personal hardware business, basically the same thing. Which is not that sad because I work for Adafruit now, which is cool.
We fully acquired the
yeah.
What's it called? Chickadee Tech.
Yeah.
In acquisitions, you can put a blog post about your incredible journey.
Yeah, I already did.
Okay.
if you actually go to Chickadee Tech, you'll see I wrote a blog post about it. It goes into like what things I learned and stuff like that. Anyway, so that's a couple things. And then I just wanted to show, I was doing capacitive touch. So I made this like really rudimentary capacitive touch thing. Unfortunately, it crashes before I could ever actually use this. So I'm working on that for
Wait, there's a cat.
microcontrollers. Yeah, she's...
Is it capacitive touch?
Capacitive touch.
Capacitive.
That also crashes, unfortunately.
Okay.
But yeah, so that's some of what I'm working on. I also got a bunch of, one last thing. I got a bunch of like cables with pre-crimp terminals and then like the housings for it. So the Soleil that is in the store, you can use the 2x4 just housing and then like break out any sort of thing that you want. So this is the one I was using for sniffing spy. And it's just like totally better than these clips that always fall off.
Man, I don't even know why I never thought of that. Before we leave, I'm totally doing that because I have to debug some iSquared-C stuff. And those little clips are so annoying.
Yeah, so these are working great because I'm using them with feathers. So I just plug them in. And if you want to know what I got, I bought them from Pololu, but maybe we should carry them.
We stock them already.
Really?
Yeah. It was John Park's idea.
All right, I'll take a look.
No, we have them. We have a male and we have them with the different sets of blocks.
Okay.
Yeah, but we stock like 3,500 things. So like, you know what? Once I accidentally stocked 2 things that were identical. Like I actually forgot that I already had the cable adapter in stock, and like, then when I searched for it, I was like, oh my God, we already had it. So it's a little bit embarrassing.
The other thing that happens is you're looking for something on the internet, and then the only link to it is Adafruit, and you stock it, and like, why was I even going? Like, what? I didn't even think to look at our own store. Yeah, it happens.
Mm-hmm.
Good problems to have.
Yep.
All right. Okay. Well, thanks, Scott.
Thank you.
Okay. Next up, Bob. Hey, Bob. How's
Hey,
it
Bob.
going? Unmute your mic and show us your project.
Hello, Bob.
Hi guys, can you hear me okay?
Yeah,
Yep.
you sound great.
Okay, I did a feather phone up project,
Cool.
and it's a little bit different. It's a cell phone in a diesel
nice.
pump style.
Wow, that's so cool.
So this is my take on what a cell phone would look like if they made one in 1940. So I got some screen shares for you so you can see a little bit better what's going on.
This is totally the phone in BioShock. You pick it up and it's like.
Yeah, I turned the backlighting off on the speaker bezel off for the show, so it wouldn't blast it out. So what do you see, Lamore?
Yeah, we can see the screen share.
Yeah, sorry, we see it. Yeah. No, I'm amazed at this beautiful
We're in awe.
radio phone.
Okay, and going on the inside, there's the back.
Oh,
So
yeah.
this is sort of my imagining of what Motorola would do with a radio or a cell phone.
Nice touch.
Yeah, like the brass. So cool.
Yeah, brass looking. Yeah, it's a art store. They call it found objects. So you go to Michael's or Joann's and get something like that. So it's just a big old stack of stuff. So we got NeoPixel Jewel underneath the speaker. And all of this stuff is Adafruit sourced. Case was milled on a CNC ShotBot and at a 1/2-inch walnut, so it's about 1 inch thick when you put it together. So yeah, there's a whole lot of origami going on here.
Yeah.
Yeah.
Fantastic work, Bob.
But you know what's funny? It's so compact actually when you hold it. It's not that big, you know?
Yeah, it doesn't seem that big. It's the footprint of a iPhone, but it's thicker.
Yeah.
So,
Way better.
You know, Samsung could
Way more wooden.
Samsung could learn something from you on their phone
I
design.
know. You're doing better than they are.
Yeah.
I actually wanted to call it the Jitterbug, but somebody named Samsung had already taken the name. That's the old people phone.
I like the brass inserts too that you got on there to attach. Is it the brass inserts that you hammered into the wood?
Yeah, they're epoxied in. So I milled out a hole for it and epoxied those guys in.
Okay.
Yeah.
This is amazing.
Oh, fantastic work. Email support@adafruit.com. We'll send you
Beautiful.
an as seen on the show and tell sticker that can go on the inside perhaps, or even
Okay, just the last thing. So it's got a flashlight function.
of course.
Yeah, of course.
You can dial. It has favorite phone numbers and also an FM radio that sounds really terrible.
Yeah.
I don't know if you can hear that. But
Yeah. It sounds
yeah,
terrible.
that's the FM radio. Yeah, so favorites on FM radio. So
That's so cool.
Fantastic work.
I love it.
thanks, guys. One
Awesome.
last thing. That's it. thisoldgeek@blogspot.com.
This old geek.
Dieselgeek@blogspot.com. Okay,
Yeah.
we'll do a post too.
That's
Okay,
so cool.
thanks.
All right,
Yeah,
thank
totally.
you so much, Bob. Wow, that was fun.
Amazing. I'm
All right.
jealous. Okay.
Next up, Adam. Adam, unmute your mic and show us your project.
Oh, we can't hear you.
Hi.
Yep, we can hear
No,
you now.
that's Aiden.
Hi.
Oh, no, Adam.
Adam.
Got it. I'm
Sorry.
back.
Hey, Adam. You're still working on it.
Yeah, Adam, we can hear you. So we'll come back to you. Try to, but we can also do maker charades later. But speaking of,
How we go to Aiden,
Aiden this time.
who's excited.
Sorry, I thought you guys were maybe mixing up my name or something. My bad. I'm sorry,
That's
Adam.
good.
Anyways, as for what I have, a while back I was searching around on eBay, as you do, and I found this, which is a 3D printer nozzle with a diameter of 2 millimeters.
Mm.
Now, usually 3D printer nozzles are closer to like 0.4 millimeters, tremendously smaller than this. So I'm not really sure why these are made, but I'm glad they are because I've been having a blast playing around with them. So here's a little vase that I printed. Maybe
Oh, chunky style.
yeah, the very thick and large layers that are on it, and it gives it a really interesting element. And printing vases with it by the spiral setting in many slicers looks really good. I've made
Yeah.
a lot of very pretty objects that by having this like bumpiness to it gives it a really interesting element, and so creates very cool intricate objects and that bumpiness is a interesting element to add to that. Additionally, a few things that are a result of printing at such a large layer height. It prints tremendously fast. This vase, which is quite tall, printed in 45 minutes, which is bananas for 3D printing.
Yeah.
Yeah.
And so it's been very cool to play around with. Also, I was investigating the acoustic effects of having that bumpiness because I really like percussion instruments like guiros, which is basically a carved gourd with bumps in it. So when you play it, it creates this nice staccato sound. So I made one, and so
Cool.
has a lot of interesting uses, except not really for precision 3D printing, but fun 3D printing nonetheless.
But I like that it's actually going opposite, right? Because for so long it's been like layer height, microns, skinnier, but again slower. I actually kind of like this. It reminds me of, you see like those scarves, like those fax scarves that are like knit out of wool that's like this thick. So it's like only like 4 knits, and it's like a gigantic chunky scarf. That kind of what it reminds me of. It's a cool style.
Yeah, next one will just be like cubes pop out.
And you have good layer adhesion. It doesn't cool off too much.
Yeah, so it's very strong layer adhesion, and because of just the sheer amount of plastic coming off, it has a lot of surface area to adhere to.
Okay.
And,
I
creates
like
very-
that too. Yeah, it's a
That's
good
neat.
idea.
I like the musical instrument.
Yeah.
All right. Thank you so much, Aiden.
Thanks, Aiden.
Email support@adafruit.com if you want to ask on show and tell sticker for that bumpy vase. And let's go back to Adam. Adam, got your
Microphone working now?
Yeah, yay.
Yeah, you're good.
Hey,
What's
very
got?
cool. Yeah, so this week I have a scanning tunneling microscope to show off.
What?
So this is based off of Dan Berard's design. It was featured on Hackaday a couple of years ago. So this thing is, for those of you who don't know what a scanning tunneling microscope is, it basically takes a really, really fine tip, in this case a piece of tungsten that's been etched to a 1 atom wide tip, and it scans it across the surface. And then there's electrons that will tunnel from whatever you're scanning into the tip, and you can measure how many individual electrons tunnel. You can determine what the surface of the substance looks like. So this thing has been a really long-running project, because it turns out that dealing with picovolts and nanometers is really, really hard. I originally in over my head when I started on this thing, but learned a lot, so that's quite a bit of fun. It doesn't quite work all the way, but I can show you a couple of the sample scans I have.
I love your suspension to avoid vibrations.
Oh yeah, vibration dampening is really bad for something like this. So this is a scan that was done earlier today. It's not great quality. This is about 300 nanometers, not millimeters wide. So
scale that down by about 30, you'll see individual atoms with the thing, but not there yet. So still working on it. This is a sample of some graphene, so you can see kind of a valley in there. And then there's another sample that shows some more peaks and valleys of graphene.
Wow.
Wow, that's so cool.
This is really impressive.
This is the opposite of Aiden's project. It's really chunky. This is like
really tiny.
Yeah.
Yeah. So the goal is right now to get down to being able to scan individual atoms. The original designer of this particular one, he was able to do that, but I found some mechanical issues with it. So instead of having this big aluminum frame right now, I'm working on replacing that with PCBs and some fancy ceramics, because aluminum expands, and then when you expand a little tiny bit, you drift out of range and you're no longer able to scan. So.
And then how do you tune it so it's right above the surface of the object?
So there's actually, it's a 3-knob tuning, so triangles are easier to stabilize. So we have these 2 in the front, and these 2 in the front are the coarse approach. And if you look down there, you can actually see the sample right there. So I bring it down visually with the front 2, and then the back one's on a lever that's about a 30-to-1 ratio. So each rotation or each degree rotation of the back lever is about 400 nanometers rotation, and I have to bring the tip within 700 nanometers to measure it, or for the software to take over control. So it's not the easiest thing, so I'm going to automate that eventually. In fact, the original designer has automated his, but I'm going to use a slightly different method. So.
Okay.
Yeah, this has been a long-running project, so almost a year.
Yeah, but this is cool. I mean,
All right. Well, I'm gonna.
who else has an SEM?
I'll send you a sticker.
It's on your table. Yeah.
You can measure the search of the sticker.
Yeah, email
Has to be
support@adafruit.com, and we'll send you.
This
a
is
sticker.
awesome.
Yeah, great work.
I have one last question. Where do you get the tungsten probe from?
So,
Is it like
that's my
tungsten
kitchen
probe
right
type?
over there. That's a etching station to use for the sodium hydroxide with a electrolysis to etch the individual tungsten tips.
Okay.
So actually, I can actually show you a photo of what the tip looks like. Yeah, parents weren't too happy about etching in the kitchen, but you gotta.
That's like my one chance on about SEM, so I'm kind of asking all the questions. Well, it's like, do you?
I like that you made it.
That's cool.
Yeah. Let's share screens again. So this is the tip that was scanned earlier today, or etched earlier today. So that is theoretically 1 atom wide. I immediately went and crashed it and wasn't unable to make another one in time for show and tell. So, yeah. But no, so that it's incredibly difficult to get these tips that small. Originally, I was trying to use pliers to pull it apart, and that wasn't working too well. So.
Okay, this is cool. All right, well, come back whenever you want to show us more scanning electron.
Yeah, and then real quick, I do want to give credit to the original guy who made this. So his website is Berard. That's DBERARD.com. He's got schematics, PCBs, and everything online. So.
Yeah.
All right. Outstanding work, Adam.
Yeah, thank you.
Scanning
Good stuff.
electron microarduino.
Okay.
Scanning tunneling microscope.
Scanning
Tunneling.
tunnel.
All right, we're going to speed run it because we only got 9 minutes. So if everyone can spend a couple minutes, we can get through everyone. Andrew.
Hey, Andrew, welcome back.
Hello.
Hello.
You can hear me this week, right?
Yes, yes.
Awesome. Appearing wasn't doing so well last week. So it's a tale of 2 feathers. The thing that I was showing last week was something I've called ThingSwitch, and you can install it using flashes. So I know that you had to install the appropriate Arduino core branch and all these other dependencies that were at the main line. So I ended up just compiling the binaries and distributing them. So it's easy, 0 code, and you can get up and running. I'm back. Yep. Okay. Cool. So I was stood on your shoulders, Lydia, and created the ESP Alexa. Alexa just had me. Alexa, turn on the green light.
Sorry, I couldn't find a device or group named Greenlight in Andrew's account.
Alexa, discover devices.
Starting discovery.
Okay, thank you.
This takes up to 20 seconds. If you have Philips Hue.
Okay. Before you set it up, you can configure it on the Wi-Fi, and then you can type in your SSID and your password, and also.
Discovery is complete. I couldn't find any
Okay, Wi-Fi, great. Okay, cool.
Were not discovered. Please press the button.
There we go. So you can actually give it a name, the device name, and then the pin number that you want to toggle on or off, and then that stores it to the device. So you don't need to go into any Arduino sketches or anything. You can just configure it on the Wi-Fi. And something else I've been working on is now I've got before I had the single displays working on in JavaScript in the Espruino runtime. I've got the dual displays now, and I'll be working on the 7-segment displays and the bicolor 8x8 soon as well. So things are progressing forward on creating libraries for JavaScript to run these things really easily on the ESP8266.
All
Okay,
right.
cool.
Outstanding. Alexa, turn the green light on. Huh? No, I don't know if it heard it. Okay. Email support@adafruit.com and we'll send you a sticker. Okay. We're going to try to get to both people. We have a little bit of time. So Peter, sorry. Got that wrong. And then we'll go to C. Scott and then we're out. Peter.
Hey. Do you hear me, guys?
Yes.
Yeah.
Good. Awesome. So last week I showed some stuff regarding the Kickstarter that we are running.
Yep.
And I wanted to show some more details today. And so my screen should be shared. Good. Here we go. So first of all, the Kickstarter, it's going pretty well. That's very nice.
Sweet.
And I wanted to show you guys the tool that we wrote. It's a plugin for Atom. You see here in the right corner, this is your display, an Adafruit touch display. It's showing this demo. And here on the right, we have variables of the application that you can just edit live. So I can pause the application and, for example, change the rotation velocity of the triangle on live, like here. I change it to, let's say, 0, 1, enter, and then continue execution, and it will move faster. So that's, I think I did this wrong here. Let's do this. There we go. And play. Yeah, that should be faster now. Anyway, so that's one part. And the other is I was working on a new version of the Blackmagic probe. So this is part of the Kickstarter. It's the 2.1. This is the B version. We were improving the reset line behavior. So now it is very nicely driven with level shifters. So we have nice crisp signals. So even if you are running long JTAG cables, this will really work very well. And yeah, so this is a 3D rendering in KiCad. So everything is done in KiCad, open source tools for the win. So here you go.
No, it's beautiful.
All right. Well, thank you so much. And if people search on Kickstarter for 1bitsy, it'll probably turn up, right?
Yeah, 1bitsy and Blackmagic probe. Yeah, they should be able to find it there.
All right.
Folks, back the stuff. It's good.
Thank you so much. And of course, email support@adafruit.com and you can get a sticker. All right.
Thank you.
Play us
Hey
out.
guys, I'll be super quick here. It's been a few weeks. Well, this is what a Kickstarter NobCon edition Prometheus looks like without its front panel on there. This one's already fully tested and calibrated. I'm just waiting on the right brass screws to show up because I kind of get anal retentive when it goes with the pieces you can actually see. You want them to look really finished because then it's what distinguishes your product from being, just thrown together versus being produced with the intent to sell professionally. Anyway, you'll notice that used an Adafruit LCD, but when I go to make more than these initial, I have them all, the 6 made, but when I go to make more of these, I'm going to put the microchip part, that I2C parallel chip, on the board and plug LCD straight down on top of it and put in. Fortunately, you can get these switches with switch bats that are like 2 inches long if needed, but I'll just place everything on the board. I like the I like your LCD, but the problem becomes with each unit, there's a tolerance that you have to deal with in getting it to come up through the bezel cutout and all that. No two are the same. And I can't spend half an hour per unit when you're making 100 of these getting it all leveled off. So I'm going to just try and do it all at once on the main board.
Yeah,
it's
totally.
just a manufacturing thing.
Yeah, no, I mean, like, that's why we release Eagle files. You should just copy and paste it direct.
Right. Well, I mean, I used your dimensioning to make sure everything mapped down correctly onto the main board. And then, I'd use that SOP 28 or whatever it is chip that is the surface mount equivalent. But, it's tolerance adjustment. It can make or break your design. Take, for example, the Galaxy Note 7. What they didn't do, I don't know if you've read the article, I said back when it happened, I bet the battery expanded and it, the separation layers they pushed together and shorted the battery and it burned. Well, they didn't mill the case any deeper than the height of the battery at rest. And when you have it in use, the battery expands. It's not thermal expansion, it's physical expansion. It's an electrochemical thing. So it's a cautionary tale. Yeah. Anyway, I know you guys got to get going, so I'll give you more next week.
Okay, cool. Yeah, come back.
Bob's phone is not going to have that problem. He milled plenty of space.
Yeah. He has plenty of battery space in there. I did want to mention one thing. Chris Gamble now lives in Chicago, and he hosts a monthly hardware happy hour downtown, and I was there last night, and I'll make a report of that on the blog, but I'll start making reports of that after each one.
Oh, yeah. Great. Tony was recently on the Amp Hour, too, so.
Great. Like I commented here, Tony looks like he's working on Future on My Head in a Jar technology there.
Yeah. All right. Well, thank you, everyone.
Okay.
Big show. Thank you, Tony. Thank you, Scott and his cat. Thank you, Pedro. Thank you, Pedro. Thank you, Scott. Thank you, Bob and his dog.
That's a great dog.
Yeah, you did. And thank you, Adam. All right. We're here every single week.
Scanning tunneling electron microscope.
That's right.
Okay.
We'll
STEM.
We'll be doing Ask an Engineer in just 1 minute. And thank you, everyone, for almost another year show and tell. What a fantastic half an hour. Got a little bit of everything tonight. Thank you, everyone.
We do this because we do this thing.
Woo!
More electron microscopes.
Yeah, that was cool.
All right. See you in a few minutes.
Bye-bye.